Today we are going to discuss chemistry KCET paper that is 2023. So let's start. So the first question you can see here that compound P and R in the following reaction are. So they have just given with the aldehyde, you can see. They have just given the aldehyde, you can see. Aldehyde we know, this aldehyde they have given is acetaldehyde. Okay, what they have given? Acetaldehyde. Now they have reacted with, you can see the Grignard reagent. You can see the Grignard reagent CH3MgBr. Correct. Now you can see we know CH3 here have negative charge and magnesium has a positive charge. Correct. And we know there will be a 2 plus on magnesium because magnesium belongs to, you can see, second group. Correct. And we know bromine has again a negative charge. Okay. But you can see here the CH3 negative act as base, or we can say act as nucleophile. Correct. But depending on the substrate, nucleophile can change, or we can say Grignard reagent can change their nature. So here we can see we have acetaldehyde, and we know here oxygen is delta negative and carbon is delta positive. So you can see the CH3 minus now behave as a nucleophile and attack on this carbon center which has a electrophilic carbon. Correct. Now you can see this bond will break and there is a formation of like this compound, you can see O minus, and we have here a nucleophilic addition of your CH3 and we have H here, you can see. Correct. Now what happens, you can see now in the second part they have given hydrolysis, that is with H3O positive. Now what H3O positive will give? It will provide H plus. Now this H plus is taken by this O minus to form, you can see, like this compound. Correct. You can see we have CH3 OH H CH3 like this, you can see. So there is a formation of secondary alcohol. There is a formation of secondary alcohol. Now you can see in the next step they have given concentrated H2SO4. Now what concentrated H2SO4 will do? You can see it is acting as a dehydrating agent. It is acting as a dehydrating agent. It acts as a dehydrating agent. So in dehydrating agent you can see what it will do. It will replace this OH minus. Correct. How it will replace? You can see this concentrated H2SO4 is basically providing the H plus. Now this H plus will be attacked by this oxygen to form a protonated alcohol, you can see like this, you can see. Correct. So now there is a removal of your water molecule to form, you can see here. Now you can see here there is a formation of CCH3 H with a positive charge. Correct. Now you can see this is a part of even elimination. Correct. In even elimination you can see there is a first formation of the carbocation and the remaining H plus, and the remaining H plus you can see is removed from this carbon and there is a formation of alkene, you can see like this, the alkene will form. Okay, like this, you can see like this alkene will form. Okay, again it just like a alpha beta elimination. From alpha carbon there is a removal of your leaving group and from beta position there is a removal of your hydrogen. So there is a formation of an alkene. Correct. There is a formation of alkene. Now you can see the second part. They have given B2S6 and H2O2 OH minus. It's a very famous reaction known as hydroboration oxidation. So you know hydroboration oxidation follows anti-Markovnikov rule. It means We have to just add water molecule to alkene in a, you can see, anti-Markovnikov manner. So according to anti-Markovnikov rule, the positive part of the reagent will attach on that carbon which has, bolo, less number of hydrogen, and the negative part will attach on that carbon which has more number of hydrogen. You can see this carbon, this double bonded carbon has less hydrogen. It means, so from water the H plus will attach on this carbon and OH will attach on this carbon. So there is a formation of, you can see, there is a formation of like CH2, OH, CH, CH3, like this. You can see here properly, if you draw properly like this, you can see H is added on that carbon which has less number of hydrogen, and OH is added on that carbon which has more number of hydrogen. That is basically anti-Markovnikov rule. So according to, this is basically our, you can see, this is our R product, correct? This is our R product. And what is our P product? You can see they are saying what is the relationship between P and R. And what is our P? You can see this is our P. This is our P. This is our P. Correct? This is our Q. Let's draw on next slide to have clarity. You can see so this is the compound first we have drawn, that is your R, and what is our Q basically? See the Q1, what is Q? This is our Q, correct? This is our Q, alkene wala is part is our Q. This is our P, so P we have to draw. See this wala P we have to draw. So what is this P? You can see CH3, CH, CH3. This is our P. This is our R. Basically in the question they are asking what is the relation between P and R. You can see, if you see dhyan se na, both have same number of carbons. It means both are isomers. Now which isomers are they? You can see if we basically IPAC, if we provide IPAC to both of them, you can see 1, 2, 3. You can see 1, 2, 3. You can see here the OH is basically on first carbon. Here the OH is on bolo second carbon. See, chain length is the same, but the position of the functional group is different. It means both are positional isomers. You can see both are positional isomers. Correct? Fine. So first reaction is basically the nucleophilic addition of the Grignard reagent in the presence of hydrolysis. Then the P part is basically like this. You can see we have formed the secondary alcohol. After forming the secondary alcohol, there is a formation of dehydration reaction. After dehydration, we have an alkene. Then after alkene, we have a hydroboration oxidation, which basically deals with hydrogen and OH ka addition according to Markovnikov rule. After that, we can see the product. Product is basically like this. P and R is basically what? A positional isomers. Correct? Fine. Let's come to the second question. That is the second question. Correct? So read the second question. They are saying aniline does not undergoes. They have given the 4 option. Now we have to understand ki which of the process will not undergo by the alene. See, we have aniline. You know aniline is like this. Correct? So you can see if we undergoes Friedel-Crafts reactions. Normally the Friedel-Crafts reaction we have a Lewis acid like AlCl3. Correct? So you can see now the lone pair of nitrogen, you can see the lone pair of nitrogen will attack this AlCl3. Why? Because you can see AlCl3 is, we know it is a Lewis acid. It is a Lewis acid, and we know nitrogen lone pair act as a Lewis base. Correct? Because this molecule can give a lone pair to AlCl3 to form, dekho, it will form like this compound. And the lone pair is donated to AlCl3. See? So it will not undergo Friedel-Crafts reaction because this nitrogen is now become a meta-directing group. correct? Now it become a metal directing group. So normally metal directing group, you can see in this case, will not undergo the Friedel-Crafts alkylation. Therefore, the incoming electrophile will not attack on this substrate molecule, correct? Fine. So the option will be A. So option will be A, correct? Now come to the third question. So according to the third question, what they are saying, the heating of a phenyl methyl ether with HI produces an aromatic compound. So basically we have to first draw what is phenyl methyl ether. So phenyl, just draw the phenyl. What do you mean by phenyl? Basically phenyl is C6H5. This is basically a phenyl basically, है ना? This is a basically phenyl. So what you have to do, देखो, this is basically phenyl, correct? When the substituent is benzene, then we can say it is act as a phenyl, correct? So now they are saying ki methyl ether. देखो, so here we have a oxygen, here we have a methyl, correct? So it is methyl, see, methyl phenyl ether, or we can say phenyl methyl ether. This is the compound basically. You have to react with HI. You have to react with HI. Now they are saying it produce an aromatic compound. It produce an aromatic compound. How basically it form aromatic compounds? You can see, we know this reagent is a quite acidic reagent. So H plus is attacked by oxygen lone pair to form a protonated ether. You can see like this. Now this H will attach like this, and we have positive charge with a single lone pair, correct? Now in the second step, so in the first step you can see H plus is attacked, correct? So you can see here. Now in the second step there is an attack of your I minus, correct? Second step will be the attack of I minus. So now you can see they are saying it produce aromatic compound A, correct? So we know it forms aromatic compounds only when it attacked from this CH3 molecule to break this OH, yeah, you can say CO bond, correct? A CO bond. Okay, there is a possibility that this I minus can attack here also, but no, it will never attack, correct? This bond has a partial double bond character. It has a partial double bond character, so it will not be broken. Or we can also say if it broken, you can see there is a formation of a phenyl cation which is very unstable, correct? Which is very unstable. So this route is not possible. This is route possible. We can say there is a formation of, you can see there is a formation of this phenol with CH3I. Phenol with CH3I. Now see, this is our aromatic compound they are saying. They are talking about the aromatic compound A. It means this is your A. This is your A. Now what they are saying, A which on treatment with concentrated HNO3. So it means, now you can see the A is basically phenol. A is basically what? Phenol. So phenol when react with HNO3, now they have given concentrated. And we know that phenol is a strongly activated donating group. So therefore, the electrophile generated from this HNO3 will be, we know this is EAS, that is electrophilic aromatic substitution, known as nitration. So we can see the NO2 plus as an electrophile which is generated from this reaction will be attached on either on the ortho or para. We know normally, but we know this phenol is what? Phenol has more strong activating group. So you can see there is a NO2 on each of the ortho and para position. So NO2 will be here, here also, and the ortho. So 2 ortho and 1 para position basically. So this is, we know this is known as a picric acid. We know this is act as a picric acid. So you can see our compound B will be, this is our compound B. This is our compound B, that is what you can see, this is a picric acid. So they are saying ki A and B respectively are, it means it is option B, phenol and picric acid. B is basically picric acid and A is basically phenol. Understand? Correct? Fine. No doubt. Let's come to the next question, that is the fourth one. So fourth one, they are saying they are given the series of a reaction and they are asking for the major product Y. Correct? Now in this reaction you can see the first reaction is the Na plus and we have OH minus. Correct? We know it act as a base. It act as a base. Now base, what actually do? It abstract H plus basically from the acid. Now we know ki phenol is act as an acid also. So now this OH will be abstracted by what? This H will be in the form of H plus will be abstracted by this OH minus. So it will convert into, you can see it will convert into the phenoxide ion. You can see it converted into the phenoxide ion. It converted into the phenoxide ion. So A will be, so A will be like this. You can see thoda sa. Let's say draw on the bottom side. So A will be like this. It will be a phenoxide ion and Na plus. This is a phenoxide ion. That is, we can also say it is a sodium phenoxide after the reaction with base. So first reaction will be the acid base reaction. So there is a formation of a phenoxide ion, or we can say sodium phenoxide. Now in the next step they have given CO2. So we can CO2 we can write like this also. Correct? Now we can see there is a nucleophilic reaction on this carbon, because we know कि oxygen is more electronegative, so it get partial negative charge, and carbon is having a partial positive charge. Correct? So now the nucleophilic part of this phenoxide will attack on this carbon to break this CO bond to form, you can see, this O will connected with, now you can see this. See, this is a reaction known as a Kolbe reaction. When we have a phenoxide and what? CO2. Correct? You know that reaction? Phenoxide with CO2. You know that reaction? है ना? There is a formation of what? You see that particular thing. You know. है ना? You know that thing. So there is a formation of a COOH. Correct? So there is a formation of what? You can see there is a formation of a COH group when it react with CO2 in the presence of H plus. In the presence of H plus. So in H plus you can see this OH is also protonated. This OH will also protonated and it converted into, you can see it will converted into OH. है ना? There is a formation of this compound. Correct? Now the second step will be, they are saying, the second step you can see, they are saying CH3 CO का whole twice and O. This is a anhydride. This is called as anhydride, and it is used as acylation. It is used as acylation. It is used as acylation. Correct? It is used as acylation. So we can see this OH part will acylated to form, you can see, like this product OCOCH3. So it is acylated. Now we have this COOH. Now you know this compound is known as aspirin. Known as aspirin. Correct? Fine. So now you can see the product will be D. The product will be D because they are asking for Y. This is the major product. Okay? Fine. So we are not going with the mechanism wala part. Correct? You can see we can also do this mechanism wala part, but this is not, they are asking, it is just of time waste. Just you know the Kolbe reaction, then write direct the product. This is the direct product. When the phenol react with CO2 in the presence of H plus. Fine. Chalo. Now come to the fifth question. What they are saying, a better reagent to oxidize primary alcohol into aldehyde. Correct? So you can see we have a primary alcohol, let's say like this. We have a primary alcohol. Now they are saying which reagent is best is basically to convert this your alcohol, primary alcohol to aldehyde normally. Correct? Now you can see the first option. Acidified KMnO4 they are asking. So in the presence of acidified KMnO4, the alcohol is converted into a carboxylic acid. It will convert into, if you take that A reagent now, that is K2Cr2O7. If you take K2Cr2O7, it is converted into RCOOH. Correct? So this will not be the correct answer. CrO3 also will oxidize your CH2OH to carboxylic acid. So B wala part B also it converted into a carboxylic acid. Now come to the D wala part. D is also converted this molecule into carboxylic acid. So the only the reagent it will act to convert this primary alcohol to aldehyde is PCC, pyridinium chlorochromate. That you have to remember. Correct? So this is again not option. So option for the fifth question, the option will be PCC, that is a better reagent to oxidize a primary alcohol to aldehyde. Correct? Fine. Understand? Sorry. Now come to the sixth part. So sixth part, they are saying that we have a cyanide basically. What we have, dekho, we have a cyanide. So right here only. Okay, this is I think visible. That is C6H5Cl, like this. This is the compound, and they are reacted with SnCl2 with HCl. This is a very common reagent, you know. This is a common reagent, I think you have seen in NCERT. This is called as Stephan reagents, or also we can say it is used in the Stephan reaction. And the Stephan reaction is used to reduce this cyanide. I think you have seen that thing. So the first step will be the reduction. Reduction, you know, what do you mean by reduction? Basically, the addition of hydrogen basically. So what happens, you can see, so C6H5, it will reduce to C6H5CH double bond NH. You know that is basically what? This is called as imine. This is called as imine. So after what they are giving, they are writing H3O positive. So there is a hydrolysis of this imine group, and we know imine after hydrolysis, it will form a aldehyde. See, it will form, this bond basically breaks. Correct? This bond basically breaks. So there is a formation of the aldehyde. Correct? This aldehyde, we know this is a benzaldehyde. What we can say, benzaldehyde. This is called benzaldehyde. Correct? So benzaldehyde on reaction with concentrated KOH. Concentrated KOH. What do you mean by concentrated KOH? You know a famous reaction that is called as Cannizzaro reaction. A Cannizzaro reaction we know. And we know this is a type of disproportionation reaction, and it will convert this data into, you can see, it will convert the benzaldehyde in acid, carboxylic acid, and in alcohol. Means basically it is giving two products. You can see it will giving its two products, a carboxylic acid and one is a alcohol, aromatic alcohol and aromatic carboxylic acid. It means the name reaction is Cannizzaro, and we know Cannizzaro reaction is basically a disproportionation reaction where aldehyde is just converted into, just oxidized to acid and just reduced to alcohol. Correct? So you can see the option will be B option. Correct? The first is the Stephan and the second one is Cannizzaro. So option B will be the correct answer. Correct? Fine. It is okay. You can see the solution. If you have any doubt, you can ask. Correct? Now come to the seventh one. How the seventh one basically they are saying, in the reaction they have given aniline. We know this is aniline. This is aniline. So aniline is converted into diazonium salt. It is a very famous compound, diazonium salt. Diazonium salt. This is called diazonium salt. So aniline is converted to diazonium salt in the presence of, you can see, NaNO2 and dilute HCl. You can see in all the options they have given, you can see in only 3 options they have given NaNO2 HCl. We know NaNO2 HCl will, or now dekho, see, we know the reagent only that is converted into, that convert your aniline to diazonium salt is NaNO2 and dilute HCl. But in this option, in B option, they have given NaNO3. So correct, this is not the option. C part you can see it is given NaNO2 dilute HCl. It can be in the third, again the last part they have given NaNO2 with concentrated HCl. Again D will not be there. So again we have A and C are given option. Correct. Now you can see that in the second step what they are saying, there is a formation of N2 plus BF4 minus. Correct. It is a famous reaction. Again we can say it is a type of Sandmeyer's and Getterman reaction. I think you have gone through. We have a series of reaction they have given in the NCERT. So you can see this will convert into N2 plus BF4 minus on the reaction with HBF4. You know this is hydrofluoroboric acid. It is called as hydrofluorobasic. We can say hydrofluoroboric acid, or we can say hydrotetrafluoroboric acid. So you can see here H is basically plus and BF4 is minus basically. So there is a removal of HCl and this BF4 will now attached with N2 plus to form N2 plus BF4 minus. So the reagent is basically used, we have here in the Q is what? You can see HBF4. Correct? Q will be HBF4. You can see only we have one option because in the A option they have given BF3. So A will not the option, C will be the option. So this is how basically you can eliminate your option if you know the series of the reactions basically step by step. Correct. Now in the second step, what will be happen? Now you can see NO2 now will react and remove this group to form NO2. है ना? So this will be the correct option. C, option C will be the correct option. Okay. Now come to the 8th part. Again देखो, this is the part of just a learning part, a theoretical concept. Okay. According to the question, they are saying कि thyroxine produced in the thyroid gland is an iodinated derivative of tyrosine that you have to understand. Correct. This is again a mug up question basically. You have to learn this question. Correct. I think the bio student, they will know. Correct. Chalo. A will be the option. Okay. You can check. Okay. Chalo. Next question will be the 9th question. So 9th question they are saying is sucrose is a dextrorotatory, but after hydrolysis the mixture shows a levo-rotation. This is because of, देखो simple सी बात है, you can see we have a sucrose. Sucrose is basically what we know. Sucrose when undergoing hydrolysis in the presence of water. Hydrolysis is basically what? In reaction with water only. It will give glucose. It will give glucose and fructose. It will give glucose and fructose. Correct. Glucose and fructose. It will give glucose and fructose. Correct. So they are saying कि glucose, sucrose is a dextrorotatory, and we have seen in the inside they have given plus 66.5. So it is dextrorotatory. है ना? Plus sign represent it is a dextrorotatory. It means this is a specific angle they have given. 66.5 is a specific angle. It means it will rotate the plane polarized light to clockwise direction basically. So it is dextrorotatory. So sucrose is dextrorotatory. Sucrose is dextrorotatory. Correct. It is a dextrorotatory compound, sucrose. But they are saying कि on hydrolysis it is converted into glucose and fructose. We know sorry. So glucose is sucrose is basically on hydrolysis converted into glucose and fructose. Initially it is dextrorotatory. So after hydrolysis you can see glucose ka specific angle they have given in NCERT. No need to learn the equation, just you have to can see the values they have given, that is 52.5, that is again a dextrorotatory, and minus 92.4. So it means sucrose after hydrolysis it forms glucose and fructose. In the final solution we have glucose and fructose. You can see the net specific angle is in minus only. It means it is a levo-rotatory. It means sucrose after hydrolysis is converted into, you can see, from plus to minus. It represent, or it says कि there is a change in the specific rotation of the sucrose. It means in the final solution what we can say, you can see they are saying that the racemic mixture is formed. No, there is no racemic mixture basically. Sorry. So you can see the B option they are given कि levo rotation of the fructose is more than the dextro rotation of the glucose. Correct. So you can see this value is more than this value. You have to just see the magnitude value. Don't go with that minus sign. This minus sign is just represent the rotation only. It rotate the light towards anti-clockwise. Okay. So you can see the magnitude wise the fructose is more than what? Glucose. Fine. Check karo. So B will be the correct option. Correct. You can see the value 92.4 is greater than what? 52.5. This minus represent is levo-rotatory. So levo-rotation of the fructose is more than the dextro-rotation of the glucose. Correct. Fine. So option B will be the correct option. So now come to the last one, that is 10th question. So you can see in this case again, you can see this is again they have given in the NCERT only. You can see that vitamin A represents what? I think it represents night blindness. Correct. So deficiency of vitamin A represent night blindness. Vitamin D is basically related to the bones only, and this bones they have given osteomalacia. What do you mean by osteomalacia? It is a softening of bone. This is called as softening of bone. Correct. Softening of bone. So vitamin D represent option 4. Vitamin E, you can see it represent muscular weakness. Correct. And the last, vitamin K, which represent increased blood clotting time. So the first one will be the fourth. First ka fourth, correct. And second ka fourth. Okay. First ka third we have, second ka fourth. Second ka fourth you can see. Second ka fourth, first ka third we can see, and the fourth and the third one is first. So option B will be the correct answer. for the 10th one. You can see. Correct? Fine.
Let's see the 11th question. Which of the following monomers form biodegradable polymers? In polymers topic, only there are 3 biodegradable polymers are there. Now here, first one is PHBV, polyhydroxybutyrate co-beta hydroxyvalerate. Second one is here dextran beta. Okay. Now third one is here nylon, here 2,6. These 3 only biodegradable polymers. Here PHBV, 3-hydroxybutanoic acid. Okay, 3-hydroxy, here butanoic acid, third position is OH, 3-hydroxypentanoic acid. Now here 3-hydroxypentanoic acid, which is a biodegradable polymer. So answer is here B, 11th question. Let's see the 12th question. Match the list 1 with list 2 in the following. Polymer question. Caprolactam, the one and only here polymer which require hydrolysis step. Vinyl chloride, styrene, propene. Okay. Now here usually this is caprolactam is the here polyamide bond. Now here vinyl chloride, here normal, here chlorine is attaching to the here sp2 carbon. Here vinyl benzene is called as a, here it is here styrene. Now propene, here normal, this is the, here it is propene. Now here polyamide, here one is, here it is D, right. Here vinyl chloride, see CH2 CHCl, this is the C. Here styrene vinyl benzene CH2 CH C6H5, this is B. Now propene, here it is CH3 CH bond CH2, now this is A. So 1 is D, 2 is C, 3 is B, 4 is A, DC, here it is BA. So answer is B. 12th question, answer is B. Now 13th question. Which one of the following is a non-narcotic analgesics? Non-narcotic analgesic, here analgesics are 2 types, narcotic and non-narcotic. Morphine, codeine, heroin, thebaine, these are the nitrogen containing alkaloids related drugs. Whereas here aspirin, acetyl salicylic acid, non-narcotic analgesic, antipyretic, which reduce the fever. Acetyl salicylic acid, here analgesic. Now here it is O, CO, here it is CH3, here C double bond, here it is OH, here 13 is, here answer is A. Now 14, this is the NCERT based question beta. Receptors are protein and crucial to body communication process. These receptors are embedded in. Okay, usually here proteins act as a receptor, you have studied in biology. Here these are present in the cell membrane. This is the direct NCERT based question. So 14th one, here answer is C. Now let's see the 15th question. A gas at a pressure of 2 atmosphere is heated from 25 degrees Celsius to the 323 degrees Celsius and simultaneously compressed to the 2/3 of its original volume. Means volume. Then the final pressure is, this is the gaseous state question. Here from the, here PV equal to, here it is nRT. Here gas is same only, that's why here we are using PV by T equal to constant. So here P1 V1 by T1 equal to, here it is P2 V2 by T2. Now look at there, pressure is the 2 atmosphere beta, initial pressure. Now initial volume I am taking the V1. Temperature is 25. Here 25 means 273 plus, here is 25. I am converting in here degree Celsius to the Kelvin scale. Now next one it is P2, that we have to find out. V2 is the compressed to 2/3 of initial. So 2/3 of initial means V1 into, here it is 2/3. Now denominator 273 plus here 323. Now here these two I am cancelling. Now here 298 approximately, this is the 600 beta. Okay, then next here P2, now this 3 will comes to here, then here it is 2 times, then 3 into 2, then here it is 6 atmosphere is the final pressure of the gas. From the PV equal to nRT, P1 V1 by T1 equal to P2 V2 by, here it is T2. Then here volume, here V2 equal to V1 into 2 by third. Here student will do the mistake usually. Here you take care. Right? So 6 atmosphere. So 15th question, here answer is D. Now 16th one, lattice enthalpy of NaCl is 788 kilojoule per mole, hydration energy minus 784 kilojoule per mole, enthalpy of the solution of NaCl. Okay, usually here enthalpy of the here solution equal to here enthalpy of the here lattice energy Le plus here enthalpy of the here hydration energy. This is the formula beta. Okay, now here we are making here NaCl. Okay, NaCl plus water we are dissolving in water. Then here you see the given lattice enthalpy is here 788. Then here hydration enthalpy, here it is plus, here minus 784. Now 88 here minus 784. Then here it is 4 kilojoule per the mole. Now this is the question from the thermochemistry. Enthalpy of solution equal to lattice energy plus hydration energy. So answer is 4, 16th one, here D option is correct. Now 17th question. At 500 Kelvin for a reversible reaction, A2 plus B2 2AB equilibrium in a closed container, Kc value here 2 into 10 to the power of minus 5. In the presence of a catalyst, the equilibrium is attaining the 10 times faster. The equilibrium constant Kc in presence of the catalyst. Here you remember, equilibrium constant will not affect the catalyst. Then here equilibrium constant cannot affect the, here it is catalyst. Whatever the value is there, 2 into 10 to the power of minus 5, same value will remain. Here 17th is, here it is B. It is not only equilibrium constant. Okay, now this catalyst will not affect the Gibbs energy, will not affect the, here it is enthalpy, it will not affect the even entropy also. These 4 parameters where catalyst here cannot influence. So 17 answer is B. Now 18th one, a weak acid with pKa 5.9, now pKb 5.8 are mixed in equal proportions, pH of the resulting solution. Now whenever salt is, both of them are weak beta, weak acid and here it is weak base. Then here in salt hydrolysis question, whenever pKa is more than pKb, in that case we can use 7 plus half here pKa minus, here it is pKb. When do we use this formula? pKa value, it is more than the pKb value, we can use this one. So the given is 5.9, 5.8. Yes, obviously pKa is more. Then here 7 plus, here it is half, this is the 5.9, here this is the 5.8. Then here it is 7 plus 1 by 2, here it is 0.1, 0.1 by 2, 0.05. Now here it is 7.05. So answer is B. 18 is here, B option is correct. pKa, pKb they have given. Weak acid, weak base, salt hydrolysis case, 7 plus half pKa minus pKb is the formula. The one and only case where pH or pOH independent on the concentration of the salt is this one. Right? So 18th is B. Now 19th question. The temperature of the 25 degrees Celsius in Fahrenheit and Kelvin scale. Here relation is important beta. The starting pages of the here NCERT of the basic concept of the chemistry. Then the relation between the degree Celsius and here it is degree Fahrenheit here. C by 5 equal to F minus 32 by here it is 9 here degree Celsius and here it is Kelvin scale. Now capital T in Kelvin, now small t in degrees Celsius plus 273.15. These are the interrelation formulas. Now 25 degrees Celsius, here I am writing 25 by 5. Okay, then here it is F minus 32, here it is 9. Now this is the 5 times, here 5 into 9, 45, here 45 plus here 32, then here it is 77 Fahrenheit. Okay, now here 25 degrees Celsius, 25 plus 273.15, here 298 point, here it is 15. Now here answer is C. Just this is the basic school level question. C by 5, F minus 32 by 9. This is the relation between degree Celsius and Fahrenheit. Now this is the formula between Kelvin scale and degree Celsius. So answer 19th one is the C. Now the number of proton, neutrons, electrons in the S2 minus respectively. Now here sulfur 2 minus, so we know they only gave in the question 32 and here it is 16 atomic number. Then here atomic number is 16, here mass number is here 32. This is atomic number equal to, here simply it is the number of the here protons beta. Okay, atomic mass A, now this is equal to proton plus here neutron number. Proton plus neutron number. Usually sulfur already it is having the 16 electron plus 2 minus charge. The meaning of here 2 minus is it is getting 2 electron here to form 16 plus 2, then here 2 electron, total 18 electrons are there. Okay, now 16 proton, 18 electron, then to get into the neutron number, the neutron number here n equal to A minus Z beta. Now 32 here minus here 16, here 16 neutrons are there, 18 electrons are there, 16 protons are there. The order is proton, neutron, electron. So protons are 16, neutrons are 16, here electrons are here 18, here 20 question, here answer is D.
Yes, now we are going to discuss about the 21st question. The question is the correct order of first ionization enthalpy of the given element. And everyone knows what is the first ionization enthalpy, what is the meaning of a first ionization enthalpy. So we have a particular element, so from this we are going to take first electron, and always you know that it is going to be an endothermic process, right? It is a positive enthalpy. Now it depends upon what factors, it depends upon mostly on the electronic configuration of the given elements. So first of all you see what are the given elements. So we have first lithium, next beryllium, next boron and carbon we have. And usually you see that these elements are present in across a period, right? From lithium to carbon they are present in a period, but we have anomaly between beryllium and boron. What is that particular anomaly? If you see the electronic configuration of beryllium, that is going to be 2s2, so which is having a completely filled 2s2 subshell, whereas for boron if you see the electronic configuration, that is going to be 2s2 2p1, so which is having something like this, a 2s2 filled orbital, and then there is one unpaired electron present in the 2p orbital. Removing the electron from 2p is very easy compared to 2s. So boron will be having lesser ionization enthalpy compared to whatever beryllium is there. So now answer is going to be this one, right? Answer is going to be this one. Sorry, not this one. So this is going to be the wrong answer. So correct answer is going to be this one. Lithium will be having the highest lowest value and carbon will be having the highest value, right? And then so we have, let's see the next question, 22nd question. So the question is about which of the following statement is incorrect, and here if you see he is talking about oxygen and its what are the ions are there. So we have O2, O2 minus 2, O2 plus 2 and O2 plus 1. So you can see the different ions. And if you see what are the bond orders are there. So bond orders, you know that for O2 molecule that is going to be bond order 2, for O2 plus 1, so bond order is going to be 2.5, and O2 plus 2 bond order is going to be 3, and similarly for O2 minus 1 bond order is going to decrease, now it is going to be 1.5, and for O2 minus 2 bond order is going to be 1, right? So now based on the bond orders, you know how bond lengths are going to change. Usually what is the relation between bond order and bond length? So bond order increases, bond length decreases. So both of them are inversely related. So based on this particular information, now what is going to be the correct answer here? So the correct answer is going to be the bond order of O2 plus 1 is less than bond order of O2 minus 2. So this one is going to be incorrect statement. Okay, right. Next question, let us see 23rd question. So 23rd question, that is very easy question. So IUPAC name of the compound is. So now here the compound is given as something like this. Now what are the rules that we have? First rule is, so you have to take the longest possible chain, which is the longest possible chain here. So starting from here, 1, 2, 3, 4 carbon atoms, right? And also you can see that there is a double bond present. Double bond is present between what carbon atoms? Second carbon and the third carbon. So double bond is starting at the second carbon. So what is going to be the correct answer then? And also there are two CH3 groups which are present at second position as well as the third position. So they are, both of them are going to be branches now. The correct answer is going to be 2, 3 dimethyl but2ene, right? That is going to be the correct answer. Now let's see the next question. Among the following is saying, among the following, the set which represents aromatic species is. Usually aromatic species, how do we identify that? So for that we have a particular rule, 4n plus 2 pi electrons, which we also call it as Huckel's rule. So now based on that, now you calculate which is having 4n plus 2 pi electrons. If you take benzene, so this one, it is having how many pi electrons? 6 pi electrons. So 6 pi electrons means we can put the value of 1. So this is satisfying 4n plus 2 rule. So 1 is going to be aromatic. Next you take 2. So this is having how many pi electrons? So this second one is having 10 pi electrons. So this is also following that aromatic rule or Huckel's rule. Next you take the fourth one. So here this one, it is not participating in conjugation. So this is not going to be an aromatic compound. Next you take, so here there are 2 electrons due to negative charge, and there are 2 pi bonds. So total 4 pi electrons. So this one is also going to be become aromatic total because it is having 6 pi electrons. So 2 electrons from the negative charge, 4 electrons from the pi bond, right? This is also going to be aromatic. And the last one, it is having 8 pi electrons. So this is not following the 4n plus 2 pi rule. So now which set is going to be aromatic now? So we have first one, second one and fourth one. Which option is that? Where do we have that? First one, second one and fourth one, that is going to be B option. Next question, 25th question, let us see. Which of the following gases converts hemoglobin into carboxyhemoglobin? So carboxyhemoglobin means that should have carbon monoxide bonded to the hemoglobin. So this is directly from the NCERT textbook only. So we can directly look at the question and answer it. So that is going to be carbon monoxide. So next one we have, what is the oxidation state of sulfur in H2S2O8? If you see the structure of H2S2O8, so it is having this particular structure. Double bond O and then OH group here. Here also we have OH group. So if you calculate, so these two oxygens, this is -1, this is -1, this is -2, this is -2, and this is -1 here, this is also -1 here. So single bonded oxygen means you can take it as -1, double bonded oxygen means you can take it as -2. So now based on that, if we calculate what will be the oxidation state of sulfur here, that is going to be simply +6, right? But if you use here there is a catch for this one. So if you use the regular formula, so you know how to use the formula, right? So sum of all the oxidation states of all the given elements should be equal to the total charge given. The molecule is neutral, so charge is going to be 0. If you use that particular rule, so here hydrogen oxidation state, usually that is going to show only +1 oxidation state, and then sulfur, we don't know, let us consider it as 2x, plus oxygen, if you take oxygen, there are 8 oxygens and usually oxygen shows a -2 charge. And based on this, if you calculate, so whatever that x value is there, you will be getting it as +7, which is wrong, right? We cannot write it as +7 here. Why? What is the reason? So we know a rule that for a given element, oxidation state cannot be greater than the group number. So sulfur belongs to which group? Sulfur is present in 6th B group or 16th group, right? So it only has 6 electrons in its outermost shell. So maximum oxidation state can be +6 only. It cannot exceed +6 value. So answer is going to be B, +6, right? Okay, next question, 27th question. Now this is also directly from the NCERT lines only. So volume strength of hydrogen peroxide, right? Usually 30% solution of hydrogen peroxide if you are taking, that would corresponds to 100 volume strength. What is the meaning of this one? 100 volume strength means, so this means if you are taking 30% solution of H2O2, you know that H2O2 it decomposes and usually it is going to decompose to give H2O plus half O2, right? So that means, so if you take 1 liter of this particular solution, so 1 liter of 30% H2O2 aqueous solution, it is always going to give 100 liters of O2 gas at STP, right? 100 liters of O2 gas at STP, okay? Right, so this is the 27th question, so this is direct and answer is going to be B here. Okay, next question, let us see, 28th question, a pair of amphoteric oxides is, right? So you know what are the amphoteric metals in periodic table, which elements, which metals are going to be amphoteric. So beryllium, which is not a metal, so beryllium is also amphoteric element. We can also have aluminum, which is a metal, zinc is amphoteric, tin is amphoteric, and lead is also amphoteric. So what are the oxides of these particular elements are there? So they are going to be amphoteric in nature. Now you see which option that is going to be, option is going to be B. So here in this question, so there is something wrong given. So it is not BO3, it is going to be B2O3. Okay, but anyways, that is not the answer. So you don't need to worry about that. So answer is going to be B here, right? Next, 29th question, let us see. The composition of water gas is. So what is water gas? So how is it produced? When coke, red hot coke is reacting with steam. So this is going to decompose to give carbon monoxide plus H2 gas. Now this particular gas mixture, this is what we call it as, so whatever syn gas or synthetic gas, or which is also known as water gas, right? What is going to be the answer now? Answer is going to be B, CO plus H2. This is also directly from NCERT. Next, 30th question, let us see. The swelling in feet and ankles of an aged person due to sitting continuously for long hours during travel is reduced by soaking the feet in warm salt water. This is because usually why does the ankles they swell? So what happens? So during the sitting position, so most of the water gets collected, right, at the bottom. So whatever that water is there, so which is coming out of the cells, so we have to remove that excess water, we have to remove. How do we do that? So we are using the process known as osmosis. So during osmosis, what is going to happen? So whenever we have a particular solution, let us say this is the brine solution we have. Brine solution means what? Brine solution is nothing but NaCl present in water. And then outside if you are keeping pure water, so just pure water only you are keeping, and assuming that whatever this particular cell wall is there, that is going to be semi-permeable. Semi-permeable means what? It can only allow whatever the solvent molecules to go through. So now because of that, whatever the water inside the body is there, because of which swelling is happening, so that swelling can be controlled. So here answer is going to be osmosis. Okay.
Yeah, let's start the question number 31. That question number 31, it is coming from the liquid solution related to the colligative property. Okay. Now let's see how it can be solved. If I take the molecule AB is a molecule and it's dissociated into A plus and B minus. Concentration of AB, it is given to you in terms of the mass percentage, and molar mass is also given to you, and from this directly I can able to say this concentration is 0.1. It is 0.1. Similarly, for the other compound, this that is also given 9.5 by 95, therefore it is 0.1. Now, if I consider at t is equal to 0 time, it is 1 mole, then it is 0, 0. At t is equal to t time, now the equation it is mentioned that 80% ionization is happened. Therefore, it will be 1 minus 0.8, that will be 0.8, that will be 0.8. Therefore, I can able to find out that total number of moles is equal to 1.8. The Van 't Hoff factor I 1.8. Similarly, for the next x, y2, x,
y2 is undergo dissociation plus 2 plus 2y minus 1. Again I assume the same thing. T is equal to 0 time, it is 1 mole, 0, 0. At T is equal to T time, then degree of dissociation is given 60. Now I'll write 1 minus 0.6, then it will be 0.6, but this will be 1.2. Now the total number of moles here, it will be 0.4 plus 0.6 plus 1.2. That means it is 2.2. These are the different von top factor for the different kind of the species here. Now, how we can able to solve the equation? For this equation, depreciation of freezing point property I into KFCM. Then I can able to write as it is depreciation, about 273 minus TF of the solution. Now I can able to make the two part. KF is constant, ICM for AB plus ICM for X, Y2. Then putting the value 1.86, von top factor for AB, it is 1.8 into number of moles of this compound, or we are taking already, it is 0.1 into 1000 by mass of the solution. Now that is important here, that mass of the solution, how we can able to write? 100 minus 5.85 minus other is 9.50. Now that will give the total mass of the solvent. Mass of solvent. Now we can able to write that value. 100 minus 5.85 minus 9.5. That is for one part. Plus next solution, von top factor is 2.2. 2.2 into 0.1 into 1000 divided by 100 minus 5.85 minus 9.5. And that will give you the TF value, and this answer will come C. Now come to the question number 32. That question number 32, it is coming from the solid state. Now it is again theoretical based question. Now you need to go through the NCERT textbook concept, because otherwise you won't be able to solve this question. Now let's see how I can able to solve this question. Molecular solid, ionic solid, metallic solid, network solid. Now the easiest way to solve this question, first ionic solid, therefore molecule should be ionic in nature. Therefore now see, this magnesium oxide is an ionic molecule. Now when there is a network form, magnesium oxide should form the ionic solid. Magnesium, it is only the metallic part. Therefore as it is metallic, if the crystal is formed, then it should be through the metallic bond. Therefore we will say it is a metallic solid. Now left only silicon, carbide and water. When it is a water molecule, it exists in a molecular form, and it can be associated with the hydrogen bonding. But when I consider this silicon carbide, then there is a network formation through the silicon-silicon bond. Therefore now it becomes easy when it is a molecular solid, ionic solid, network solid. Therefore in such kind of, if you are not sure, then you can able to use the elimination method also, and that will be easy. Now let's see how elimination. Ionic solid Q, and we already get it as magnesium oxide. Therefore Q you try to match 4, 4, 3, that one. Therefore you discard this two. Therefore you need to check now A and B. A and B, Q already it is same, then you see it will be P and P. P it is given, it is, and for here this option it is magnesium. Already we discussed magnesium can't be a molecular solid, it should be the metallic solid. Now see, metallic solid R should be matched with R is matching with 2, therefore that will be the correct answer. Therefore say elimination method will work very easily to solve this type of the equation if it is a theoretical base. If it is numerical base, then you have to go through this problem each by each step, but here you can able to use the elimination method. Okay. Then we move to the next question. Now this is also coming from the solid state, but this is somewhat the calculation based concept. Now it is given, it is a body center cubic lattice and metallic radius is given. Now we have to find out the volume of the unit cell in a meter cube. Now let's see, when it is a body center cubic lattice, then we can able to draw the body center cubic lattice yes. Position of the elements should be corner as well as a body center. Now that is a body center cubic lattice. Now let's see how you can able to link the radius and the edge length. Now I assume this is the edge length A, and if the body center cube, that one thing I think all of you know, that diagonally all elements should be connected. If it is diagonally connected, what will be the diagonal distance? It will be nothing but root 2a. And as it is connected, if I consider this is 2r, this is r, this is r, now we can able to make the relation 4r is equal to root 3a. Now see in the equation, metallic radius is given. Therefore, from the metallic radius, I can able to find out the value of a. Now, just you put the value. 4 into root 3 is equal to root 3a. Sorry. Root 3 cancel. Therefore, a should be 4 Armstrong. Now the question is what will be volume of the unit cell, as it is a cubic lattice, therefore volume should be a cube. Therefore it is 4 into 10 to the power minus 10 whole cube meter cube. Now it is 4 into 10 to the power minus 10 into 3. What should be that value? Now we can able to check. Therefore it is 64 into 10 to the power minus 3. Now we have to look from the option. 6.4 10 to the power minus 29. Yes, that can be correct, because it is 6.4 into 10 to the power minus 29. Now you can able to get that what can be the correct answer. That will be A. Okay. Therefore this is from the solid state. Therefore easily looking to the diagram, and basic formula is this. Now that is a very important formula here. Using this formula we can able to solve this question, then what it will be. Okay. Then we move to the next question, 34. Now you see from the solid state multiple questions are come continuously. Now let's see one by one. This is coming from again solid state related to simple cubic lattice, body center cubic lattice, face center cubic lattice. Now to answer this question, first of all you should know how the simple cubic lattice, how it is a body center cubic lattice, and how it will be the face center cubic lattice. Now first I will draw all this lattice. This is simple cubic lattice. Now body center cubic lattice. These are the corner position, and one should be present in the body center. Next is given is the face center. Now if it is a face center, similarly we will draw the face center cube. One is a face center, corner position will be occupied by the element as well as the face center. Now here the important thing is that how edge length is related to the radius, because everything you have to find out with respect. Now if it is a simple cube, this is A, therefore we can able to write that 2r is equal to A, therefore r is equal to A by 2. We get the because you have to find out the radii. The simple cubic lattice we are getting A by 2. Okay. A by 2, A by 2, A by 2, everywhere it is there. Then you take the second. Just before previous question only we have discussed that here the relation, as it is diagonally connected, therefore 4r is equal to root 3a, therefore r is equal to root 3a by 4. That is for BCC, that is BCC, that is simple cube, and that is FCC. Now FCC, the face diagonally it is connected. Therefore if the face diagonally, then we can able to write 4r is equal to root 2a, therefore r is equal to a by 2 root 2. This. Now look to the option. A by 2, A by 2, root 3 by 4, root 3 by 2. Here it is root 3 by 4. Next, A by 2 root 2, that was A by root 2. That was your answer will be this. Is it clear? Okay. Therefore, simple you see, if you know the basic formula of it, without drawing the structure, you can able to make it. Okay. Then we move to the next question. Now, the dimerization of the solute molecule in low dielectric constant solvent is due to. That is again a theoretical concept. Now, if it is a theoretical concept, then how we will solve it? Now, see, this problem, you can able to relate some of the molecule. If you relate some of the molecule, it will become easy. And best example to explain this, in NCERT book also given, it is dimerization of acetic acid. This, then we know it dimerized like that in a non-polar medium. But if it is a polar medium, it get dissociated into acetate ion and H plus ion. Now here it is given, if the dielectric constant value is low for the solvent, that means it will have a less polar character. Now if it is a less polar character, then the molecule can be associated like that. That means your answer will be hydrogen bonding. Therefore, dimerization of solute molecule in low dielectric constant solvent, it is because of this kind of hydrogen bonding. Right? Then we move to the next question, question number 36. Right? Now, for the reaction value, this is coming from chemical kinetics. The chemical kinetics, here rate constant, it is related to the Arrhenius factor. Then you need to know what is the relation between the rate constant and the Arrhenius factor, and that is the Arrhenius equation. Arrhenius equation K is equal to A exponential power EA by RT. Now condition given that infinitely high temperature. If it is infinitely high temperature, T is too high, and that means exponential power 0, therefore it will become A. Therefore it is A. At infinitely high temperature, K should becomes A. And that is why when you learn the significance of A, that is also known as maximum rate constant value. Now if it is a maximum rate constant value, then it is the equation, the value of the Arrhenius factor A at infinitely high temperature, therefore it should be the same value, 6 into 10 to the power 5. Therefore your answer will be B. Therefore, this equation is very simple. Just you have to know the logical approach. If someone remember that what is the significance of A, maximum rate constant value, then directly you will get the answer. But if you don't remember, then you have to go for this Arrhenius equation to solve this question. Okay? Next, we move to the next question, question number 37. Then this is also a simple questions. Again, it is coming from the same concept, Arrhenius equation, relation between the rate constant, that Arrhenius parameter, activation energy. Rate constant K1 and K2 for two different reactions are, one is this and other is K. Therefore, already I have mentioned that K is equal to A exponential power EA by RT, that equation. That gives the relation between the rate constant, activation energy, temperature and Arrhenius parameter. Now, what is the data given? That first thing, it is actually the Arrhenius parameter. This part, exponential power EA by RT. Now, if the K1 and K2 is same, that means I can able to write for both cases 10 to the power 6 into exponential power minus 2000 by T should be equal to, second one, 10 to the power 15 into exponential power minus 1000 by T. That has to be equate because K1 is equal to K2. Now, if this is the case, now how you can able to just do the simplification? 10 to the power 15, 10 to the power 16, 10. Therefore, I can able to write 10 is equal to, this exponential term go into other side, exponential minus 1000 plus 2000 by T. Now you need to solve it. Then how we can able to solve it? As it is exponential, therefore I take ln in both sides, then it will be become plus 1000 by T. Now I take to the Nesser logarithm, 2.303 log 10 to the base 10 is equal to 1000 by T. Log 10 is 1, therefore temperature it should be 1000 by 2.303. The 1000 by 2.303, your answer is A. Therefore A will be the correct answer. Therefore you say two equations come continuously from the Arrhenius equation. Now if you know this equation, then easily you can able to solve both the equation. Okay. Now we move to the next question, 38. It is coming from electrochemistry. Here it is given electrolysis. Two important points you have to know. One important point, what is the meaning of brine? During the electrolysis of brine by using inert electron. Therefore, when you say it is a brine solution, that means it is sodium chloride solution. Now, when I say it is a sodium chloride solution, that means you have Na plus Cl minus along with water. Now, it is given cathode and anode. Then in electrochemistry, we know if it is anode, oxidation should happen and cathode reduction should happen. Now, if you know this basic point, then it will be very easy to solve this question. First one, sodium deposit in cathode. Yes, there is a possibility for the reduction of sodium, but here there is a possibility for the release of hydrogen also because H plus is there. But sodium is highly electropositive. As sodium is highly electropositive, in aqueous solution it won't deposit it, therefore that will be incorrect. Next, hydrogen is liberated. If hydrogen is liberated, yes, hydrogen when it is there, there will be a reduction. Hydrogen should be liberated if it's in cathode, therefore that option is gone, D. Now leave B and C. Oxygen from the oxide and chlorine from the chloride. Then you have to look, chloride is there and hydroxyl is there. Now out of the chloride and hydroxyl, now which can be oxidized easily? Now, two ways you can able to solve this question. One way, if you know what will be the oxidation potential of the respective value, or you can able to do the discharge potential theory. As per the discharge potential theory, chloride can be discharged easily than OH minus. Why? The oxygen will have a lesser tendency to donate this electron in comparison to the chlorine. Therefore, chlorine will be liberated in the cathode. Then what will be the reaction? Chloride converted into chlorine through the release of 2 electrons. Therefore, there is an oxidation happen for the chloride, and from -1 to it becomes 0. Therefore, chlorine will be liberated in the anode. Therefore, it is a simple question. Just you have to know what will be discharge potential for chloride and hydroxyl. If you know chloride and hydroxyl, what will be discharge potential, then easily you can able to solve this question. Right? Now you move to the next question. Now this question, again it has come from electrochemistry. Now to solve this question, it will be easier method will be if you remember what will be the Nernst equation. If you remember the Nernst equation, then easily you can able to solve this question. Now it is asked about the reduction potential. Now for that, first of all, you write that what will be reduction reaction for it. Reduction reaction for silver, silver plus take 1 electron and will be converted into Ag. That will be reduction reaction. Therefore, if I use the Nernst equation here, E reduction, it should be equal to E naught reduction minus, temperature is not mentioned anything, therefore I can able to assume the standard temperature also, 0.0591 by number of electron exchange 1, then log of reaction quotient. This is solid and that is aqueous, therefore solid is not coming in this reaction quotient expression, therefore you have to write Ag plus concentration. Now I can able to modify this expression just to make it easy for this simplification. How it can be? E naught reduction, sorry, it should be reduction it is reduction. Now I make it plus. Therefore, if I make it plus, I can able to write 0.0591 by 1. Point 0.0591 into log of concentration of silver ion. Now say it become very simple now. E naught reduction, it is given to you. That will be constant value for every cases. That means entirely E reduction will be depends on the concentration of Ag plus. Higher will be the concentration of the silver ion, higher will be the E reduction. Now check where it is. This is 0.001, that is 0.1, that is 0.01, and this is 0.001. The concentration in B cell, it will be the highest. Therefore, reduction potential of B should be highest. Then check it. Only one option is missing. Therefore, your answer should be C. No need to do anything. Just I can able to say from here. This is highest. One option is given B, or you can able to compare. After B, next option is 0.01. After that, next option is 0.001, and last option is the same thing. It is coming. Therefore, just you need to know what will be the reduction potential expression. If you can able to write down this reduction potential expression, it will become very simple to solve it. Okay? Now we move to next question. Now this is again from the electrochemistry. Okay? This is somewhat the conceptual. Okay? Other questions are very simple. Just you can able to solve it in a 1 line or 2 line. Now let's see how we can able to solve it. 0.1 molar weak acid, conductivity of the cell is given. Cell constant value is also given to you. Now lambda naught value, that is also given. Now pH of the solution you have to find out. Now let's see how you can able to find out the pH of the solution. And it is mentioned it is a weak acid. If it is a weak acid, you should write HA is in equilibrium with As plus A minus. If I assume at T is equal to 0 time concentration of C, then it is 0, 0. At T is equal to T time, if alpha is the degree of dissociation, then it is C alpha, C alpha. That means you say As plus and concentration is C alpha. And what is alpha? That we can able to write lambda for HA by lambda naught for HA. That means you can easily find out that what can be the As plus ion concentration here, that is C alpha. That means C into lambda by lambda naught for HA, HA. Lambda naught for HA is given to you. This is. Then you need to find out the lambda. What is the formula for lambda? Lambda, that means conductance is equal to kappa into 1000 by concentration. Concentration is given to you as 0.1. Now you need to know the value of kappa. How you can able to find out the value of kappa? Then you have to go back again to the basic relation of conductance. If you know the very basic relation of the conductance, then it will become very simple again. Then let's see how we can able to do. We know resistance is directly proportional to L by A, or I can able to write that is equal to rho resistivity LA. That means I can able to make the 1 by R is equal to 1 by rho into A by L. Or it will be better if you can able to mark it in this way, then it will become easy for this equation. I can able to write it as minus, because L by A value is given to you, this. Therefore, I will put the respective value. 1 by R, the resistance, this is given to you. 1 by 2 into 10 power 3. 1 by rho is nothing but kappa. L by A is also given to you, it is 0.78. That means I can able to find out K should be equal to 1 by 2 into 0.78 into 10 to the power 3. That will be K. Now if I put this K value here, then you can able to get the value of lambda. Therefore, let's see how we can able to get this value of lambda. Thus I am writing this side. Lambda is equal to K value we found already 1 by 2 into 0.78 into 10 to the power 3, that is the K value, into 1000 by 0.1. This 1000 cancel, therefore it will become 1 by 0.1, 0.2, 0.2 into 0.78, that will be the lambda value. Therefore, now you have to put this value here. Now I will write, this is lambda is 1 by 0.2 into 0.78, and lambda naught value is given 390. Therefore, you know that what will be the value of alpha. Now, after calculating the alpha, I have to put this value in the C alpha, that will be an S plus concentration. Now, the question is asked about the pH. And what is the pH? pH is equal to minus log of S plus concentration, that means minus log of S plus, here it is nothing but C alpha. And alpha value already we calculated. Once you put this alpha value here, then you can able to find out what will be pH value. And then answer is coming for it 3. Now this is somewhat lengthy, step by step you have to do, and once you solve the complete equation step by step, then easily you can able to find out it. Solution is somewhat become difficult here. But if you solve this carefully, then easily you can able to find out what can be the answer for that question.
Next question, question number 41. Here, which of the following reactions have 0 rate constant mole per liter per second? So with respect to units of rate constant, mole per liter whole power 1 minus n second inverse. Here when you keep n is equal to 0, that is for 0 order reaction. N is equal to 0, therefore mole per liter dot second inverse, which is also you can write per second. So now here the order of the reaction will be 0 as per the question. So when we can say the rate of reaction, then the order of the reaction is 0. So the rate of reaction is completely depends on number of active sites of the catalyst. So if we take the reaction 2HI, that gives rise to H2 plus I2. Here the catalyst is gold catalyst. Here the rate of reaction is completely depends on number of active sites of the catalyst, but irrespective of the concentration of the reactant. So therefore we can write R is equal to rate constant into concentration of hydrogen iodide whole power 0. So the rate of reaction is completely depends on number of active sites irrespective of the concentration of, independent of concentration of hydrogen iodide. So that's why the reaction which is decomposition of hydrogen iodide on the surface of the gold is an example of 0 order reaction. Next question 42. For the formation of which compound in Ellingham diagram delta Z naught becomes more and more negative? So if you see Ellingham diagram, so this is delta Z naught versus temperature. Here there are graphs here, there are 3 graphs. Here this one C plus O2 that gives rise to CO2. Here 2CO plus O2 that gives rise to 2CO2. This is 2C plus O2 that gives rise to carbon monoxide formation. So here the formation of carbon monoxide, if you go from left to right as the temperature is increasing, so the graph which is becomes more negative. So more negative, delta Z naught is more negative, so it is more spontaneous. So the formation of carbon monoxide from carbon by reacting with oxygen is highly negative, so highly spontaneous. So here the formation of carbon monoxide will be highly spontaneous at high temperature. At low temperature it is less spontaneous. So as per the question, if increase the temperature, it will become more spontaneous. So therefore, formation of carbon monoxide, the curve is going to right side as the temperature increases, right side, delta Z naught becomes more negative. So, here it is a less value, that means negative value here. This is negative values. Next, which of the following compound does not give dinitrogen on heating? Here the answer can be A maybe. So, why? Because if you write ammonium nitrate on heating, it will give nitrous oxide plus 2H2O. Heating of ammonium dichromate, that is NH4 twice Cr2O7, on heating it gives N2 gas plus Cr2O3 plus 4H2O. Next, heating of barium nitride, which is also called barium azide, it gives barium metal plus 3N2. And heating of ammonium nitrite, NH4NO2, on heating it will produce as N2 gas plus 2H2O. If you observe all the reactions here, the second reactant will give N2 gas, third reactant will give N2 gas, even fourth reactant is also will give N2 gas. But here only ammonium nitrate will give nitrous oxide, which is also called laughing gas. So, as per the question, the nitrogen cannot be produced from the ammonium nitrate. So, as per the question, answer will be option A. Next, aqueous solution of raw sugar when passed over beds of animal charcoal, it becomes colorless. So, it becomes colorless because here the color of aqueous raw sugar can be absorbed by animal charcoal. So, this is the charcoal, here the surface sides of the charcoal, here the colored matter in the aqueous sugar solution, the colored matter can be absorbed by animal charcoal. So, that means here color is getting absorbed by an adsorbent. So, this is an adsorbent and the colored matter is absorbate. So, coloring substance is absorbate and the animal charcoal, this is the animal charcoal, So, animal charcoal, which is an adsorbent that adsorbs, so this is the colored matter. So, the process is called adsorption. The process is called adsorption. So, the process of adsorption entire. So, here the process is adsorption and the adsorbent is animal charcoal. So, therefore, for the 44 question, option A will be the correct answer. Next, Freundlich adsorption isotherm, a graph of log of x by m versus log p. Here, if you see the relation between x by m versus log x by m versus log p, log x by m is equal to 1 by n into log p plus log k. So, this is exactly equal to y is equal to mx plus c graph. So, then how do you draw the graph here? So, y axis is log x by m and x axis you can write log p. Here the slope will be here, slope is equal to, which is m here. So, this is 1 by n. So, here for a given question 45, the answer can be slope will be 1 by n and here the point of intersection, this is log k. So, which is log k. So, answer will be D option for the given 45 question. So, next, when ferric chloride is added to excess of hot water gives solution is X. When FeCl3 is added to the sodium hydroxide solution, then it will become Y. So, when you add ferric chloride solution to the hot water, so this is the hot water. Here we added ferric chloride solution. Then what happens? So, ferric chloride FeCl3 will react with hot water to form Fe2O3 dot XH2O. Now, here the substance will be Fe2O3 XH2O. Now, this Fe2O3 is a like kind of precipitate that adsorbs Fe3 plus ions. When you are adding FeCl3, then it will become Fe3 plus ions also there in the solution. Now, here this Fe2O3 O3 XH2O that will adsorb Fe3 plus ions, then it will become Fe2O3 dot XH2O slash Fe3 plus. So, this will be colloid will be obtained in the solution. So, that means here the precipitate which is formed Fe2O3 that adsorbs Fe3 plus ions, then it will become a colloidal solution in the solution. It will become a colloidal solution. So, here for the first part of the question it will be Fe2O3 dot XH2O slash Fe3 plus, then it will become positive colloid. It will become positive colloid. When you take second part of the question, the same FeCl3 if you add it to the sodium hydroxide solution, this is NaOH solution. So, Na plus OH minus ions are there. Same FeCl3 we are adding here. When you add FeCl3, then also it will form. So, FeCl3 will react with hydroxide ions in the solution. So, here also the same precipitate will be obtained, which is Fe2O3 dot XH2O. Now, that Fe2O3 dot XH2O will get precipitated, that precipitate immediately again it adsorbs OH minus ions from the solution. That OH minus ions is obtained by sodium hydroxide solution. So, now here Fe2O3 dot XH2O, this is Fe2O3 dot XH2O adsorbs this OH minus ions. So, it will become negative colloid, which is in the solution, which is found in the solution. So, that means the precipitate turns to colloid. Here also the precipitate turns to colloid, which is positive colloid. In this case negative colloid. Why? Because that Fe2O3 dot XH2O that will be adsorbs OH minus ions, then it will become negative colloid solution. So, that is why for the given question answer will be B. Next question, the reducing agent in the solution. So, the reducing agent here, this is the extraction of gold can be here as per the equation here, or maybe zinc here, gold or silver. So, the silver is reacting with cyanide ion solutions from cyanide ions by in presence of oxygen here. So, here Az will become Az plus here. So, undergoes oxidation in the first step, and the second equation Az plus 1 will become 0. So, that is the reduction. Next, zinc will undergo oxidation. Here zinc oxidation state is 0, then here zinc oxidation state will be plus 2. So, zinc undergo oxidation, hence it is a reducing agent. So, in this question zinc will be the reducing agent. So, therefore, for a given question answer will be C. Next 48, which of the following is correct with respect to melting point of transition element? If you see 3D series of elements, so this is melting point, here atomic number. So, the graph will be like this is the chromium, after that manganese and iron, and this is the graph. Here this is the chromium and here manganese, here is iron. So, as per this graph, chromium having highest melting point since it have high number of unpaired electrons and having high metallic bonding between one chromium metal to another chromium metal. So, that is why chromium having high melting point, after that manganese. So, as per the graph, so correct option will be D for a given question. Next question, MnO4 minus ion is reacting with thiosulfate to form manganese dioxide and sulfate in the basic medium. If you see the balancing of equation, MnO4 minus ion is reacting with S2O3 2 minus, which is thiosulfate, that converting into MnO2 plus SO4 2 minus. Now, here we can balance the equation. Here as per the question they are asking A and Y. So, we have to find the coefficient of sulfate, which is Y here, and here the coefficient of manganese, which is A here. So, A and Y we have to find. So, now the oxidation number of manganese here, it is a plus 7 here. Here oxidation number of manganese is plus 4 here. So, the difference in the electrons will be 3 electrons. Now, if you see the oxidation number of sulfur will be, here it is a plus 2, here the oxidation number of sulfur is plus 4 here. So, the difference in the oxidation number, but here 2 sulfurs, here 2 sulfates I am writing. Now, the difference in the oxidation number is 2, here it is a plus 6 here. So, the difference in the oxidation number will be plus 6 minus plus 2, which will be plus 4, but it is a 2 electrons into 2 here. So, it will be 8 electrons. So, now here, so the loss of electrons here, which must be equal to gain of electrons here. So, then here I have to multiply it with 3 here, here I have to multiply it with 8. So, 8 3s are 24 electrons by gaining by here we have to multiply with 8 here. So, A will be 8 here and here also will be 8. Now, here 3 you have to multiply 3 S2O 3 2 minus and 3 2s are here, 3 2s are 6 here. So, here the quotients of sulphate will be 6 and the quotient of permanganate will be 8. So, 8 and 6. So, D option will be correct option for a given question. Next, which formula and name combination is incorrect? Here if we observe first one, the oxidation number of cobalt here X. So, cobalt oxidation number for A option X plus 2 chlorides 2 into minus 1 and here is minus 1 here. And ethylene 1,2-diamine oxidation number is 0 into 2, which is equal to 0, that implies X is equal to plus 3. Here oxidation number of cobalt is plus 3 here, oxidation number of cobalt is plus 3, but as per the given name of this question, dichlorido, here it is a di is there, but ethane 1,2-diamine is a didentate ligand, it should be bis here, and oxidation number of cobalt will be plus 3, but here is given plus 2. So, that is why it will be incorrect name of this formula. So, for a given question 50, answer will be A.
Hello students, our next question is 51. Let us read the question. Which of the following system in an octahedral complex has maximum unpaired electrons? So, first let us focus on this octahedral complex. So, first let us understand what is the crystal field splitting pattern of octahedral complexes. For example, if you assume this is the energy and the crystal field splitting in octahedral complex are going to happen in this manner. Clear? The crystal field splitting in octahedral complexes are going to happen in this manner, right, where T2g orbitals will get lower energy, whereas Eg orbitals will get higher energy, right. These are T2g orbitals, whereas these are Eg orbitals. Let us see here the question whatever they are asking here, which of the following octahedral complex has maximum unpaired electrons, that is what they are asking. Observe carefully, first one D4 low spin, whenever low spin is there means what, we have to pair the electrons. So, D4 low spin, which means what, first electron, then followed by second electron, third electron and fourth electron. So, we should pair like this. So, the number of unpaired electrons are 2 here, okay, number of unpaired electrons are 2. Let us check the next question, D7 high spin. So, in this case what happened, I am going to draw a new diagram for this, observe carefully. For example, if it is D7, what happens, you are going to have like this. For D7, that too what they mentioned? They have mentioned high spin. Then we have to fill the electrons in this manner. D7 high spin. So, first electron, second electron, third electron, fourth electron, fifth electron, then followed by sixth electron and seventh electron. So, after filling that 7 electrons, we have 1, 2, 3 electrons left. So, n value is 3. Is it clear? And observe the next one, and observe the next one, and observe the next one. For example, if I draw the pattern for the next one, what is going to happen? For the next one, it will be like that. For the D9 high spin configuration, if you assume this is energy and this is a crystal field splitting, then what happened? D9 high spin. So, we should fill the electrons in this manner, like high spin 1, 2, 3, 4, 5, 6, 7, 8, 9. So, only 1 electron is left. So, n value is equal to 1 over here. What about the D6 low spin? For this let us discuss. This is energy and the crystal field splitting, it will happen in this manner. T2g orbitals below, Eg orbitals above. Now here D6 low spin they have mentioned, D6 low spin. So low spin is nothing but what? First electron here, second electron here, third electron here, fourth electron here, fifth electron here, sixth electron here, because it is low spin, it is not high spin. So n value is 0. So after drawing these crystal field splitting energy diagrams, then it is identified that here n value unpaired electrons are 2, unpaired electrons are 3, unpaired electron is 1, whereas unpaired electron is 0. So the final answer is B is the correct answer. Clear? Let us go to the next question. The next question 52, the correct decreasing order of basicity of hydrates of group 15 elements is. Observe carefully, in the 15th group elements, in the 15th group element hydrates, remember carefully, as central atom size increases, as central atom size increases, then what happened here? Lone pair more stabilizes, lone pair more stabilizes. So as central atom size increases, lone pair more stabilizes. So what happened? If lone pair more stabilizes, it cannot donate easily. So basicity will decreases. Okay, so which means compared to nitrogen, which means nitrogen is the first hydrate, nitrogen will be more basic nature, after that phosphorus, then followed by arsenic, then followed by antimony, then followed by bismuth is the correct answer. So the answer is B. Is it clear? Let us see the next question. The next question is, which one of the following oxo acids of phosphorus can reduce AgNO3 to metallic silver? Okay, here remember carefully. So if any phosphorus in any phosphorus oxy acid, if it contains at least one pH bond, then it can reduce Tollens reagent. So the main criteria is phosphorus oxy acid should have phosphorus oxy acid should have at least one pH bond, If it is having at least one pH bond, it can reduce Tollens reagent. Now let us see this structure. First one, A structure. What is that? H4P2O6. In this case, what happened? H4P2O6, we can draw like this: P single bond P and double bond O, OH, 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 OH. There is no pH bond over here. Clear? There is no pH bond. Whereas if I draw the second one, H3PO4, how I can draw the H3PO4 structure? H3PO4 structure we can write like this: P double bond O, OH, OH, OH. Here also there is no pH bond. And what about this one, H3PO2? If I write H3PO2, in this H3PO2, I can write like this: P double bond O, one hydrogen bond as well as one OH, and another also I can write hydrogen bond. Here P double bond O, H, H, OH. There are two pH bonds is there. So definitely it can reduce AgNO3 to metallic silver. So this will be the correct answer. So for our further clarification, let us see this option also: H4P2O2. H4P2O7 structure is what? That will be P double bond O, single bond O, P double bond O, OH, 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 OH. It will come like this. Even here also there is no single pH bond. So the answer is C. 53 answer is C. Clear? Let us go to the next question. That will be, in the solid state, PCl5 is an, first option, ionic solid with PCl4 plus and PCl6 minus. Second option is covalent solid present in the form of P2Cl10. Third option, octahedral structure. Fourth option, ionic solid with PCl6 plus in PCl4 minus. This is directly remembering question. Remember carefully, PCl5 exists as ionic solid with PCl4 plus and PCl6 minus. Simply we can understand like this: if we take two PCl5 molecules, what happens now? One PCl5 molecule will lose one chlorine, another PCl5 molecule will gain one chlorine. In the process of losing one chlorine, what is going to happen? This will convert it to PCl4 plus and this will convert it to PCl6 minus. But anyhow, it is a remembering question. You should remember that is option 1. In the solid state, PCl5 exists as ionic solid with PCl4 plus and PCl6 minus. Let us discuss the next question. 55. In which of the following pairs both element does not have n-1 D10 NS2 configuration in its elementary state? Listen carefully this question. They are asking both element does not have n minus 1 d 1 to 10 ns2 configuration. Remember carefully, this is group 12 elements configuration. This is group 12 elements configuration. So do you know what are group 12 elements? These are zinc, cadmium, mercury and copernicium, Cn. Zinc, cadmium, mercury, copernicium. Observe carefully, which of the following do not have this configuration? If you observe the first one, mercury and copernicium, there belongs to 12th group, so first one is not correct answer. When in the same way you take C option, zinc and cadmium, even zinc cadmium belongs to 12th group, so even C also not correct. What about D? Cadmium mercury, even they are also belong to group 12, so even this is also not correct answer. But what about this one, copper and zinc? In this copper is not 12th group, it is belongs to 11th group. But in this question they have mentioned both the elements, but here only one element do not have this configuration. But even though there is no option for this question, but most relatively we can take B. But frankly telling, for this question no option is given, but most relatable answer we can take B. Is it clear? Done. Next question. 56, that is CH3 CH double bond CH single bond CH2OH in the presence of PCC converted to CH3 single bond CH double bond CH single bond CHO, which means here alcohol is converted to carbonyl group, which means aldehyde group, we can say that. So the hybridization change involved in the C1 in the above reaction they are asking. Observe carefully, first of all you should identify what is C1 carbon over here. Here observe carefully, from the alcohol we should start giving numbering. Here it should be 1, 2, 3, 4. In the same here also 1, 2, 3, 4. So this is the C1 carbon. At this C1 carbon, if you clearly observe, it is involved with all the single bonds. So here carbon, hydrogen, hydrogen as well as oxygen, OH is there. So this is called as sp3 carbon. This is called as sp3 carbon. What about this? If you observe that C1 carbon, it will be like a double bond CH, single bond C double bond OH. Here carbon involved in double bond, so it is having planar shape. So this carbon is sp2 carbon, and moreover the aldehyde carbon is sp2 carbon. So the answer is what? It is converted from sp3 carbon to sp2 carbon. Where is the option? sp3 to sp2. So the answer is D. 56 D. Next question. Clear? 57. If a bidentate ligand ethane 1,2-diamine is progressively added in the molar ratio ethylene En ratio to nickel in 1:1, 2:1, 3:1, 2, NiH2 6 times plus 2 in aqueous solution, following coordination entities are formed. And they have given some more data, like what happened, the first complex which is formed, nickel H2 4 times En plus 2, aqueous, and which color is pale blue, nickel H2 twice, En twice plus 2, which color is blue or purple, and third complex they have given nickel En thrice plus 2, which color is violet color. And the wavelength in nanometers of light absorbed in the case of 1 and 3 are respectively. For this entire question, we can solve this question very easily. You know what? Whatever the wavelengths they have given here, and here remember pale blue, blue and violet, whatever the colors are there, they are visible region colors. They are visible region colors. Visible region colors. Right, am I correct or not? In the given options, first one 310 nanometer is not visible region range. Even here 310 nanometer not visible region range. Here also 300 nanometer not visible region range. Simply we can tell the third option like that. But by using another concept also we can tell third option is correct. Let us discuss carefully. In these cases, if you observe these three complexes carefully, in this first complex what happened, here we have 4 weak field ligand is there, 1 strong field ligand is there. If you observe third complex, there are 3 strong field ligand is there. Remember here concept, energy of ligand is inversely proportional to wavelength absorbed. Which means if strong field ligand is there, less wavelength is absorbed. If weak field ligand is there, more wavelength is absorbed. So remember carefully here 4 weak field ligands is there. So it will absorb more wavelength. Here 3 strong field ligands there, so it will absorb less wavelength. So first of all you should have more wavelength followed by less wavelength should be there. In the given options only more followed by less only here. You may confuse with the third option, but the point is here 310 is not a visible region range, so definitely we should go for the option B. So option B is correct answer. 600 nanometers and 535 nanometers is the correct answer. Clear? Let us go to the next question, that is 58th question. which of the following is an organometallic compound? So remember carefully, what is the main criteria for an organometallic compound? Organometallic compound. Organometallic compound is nothing but it should have metal carbon bond. It should have metal carbon bond. It should have metal carbon bond. If any element is having metal carbon bond, that is called as organometallic compound. If you observe in the first case, calcium is connected to oxygen. In this case, sodium is connected to oxygen. In this case, sodium is connected to oxygen. But in the last case, magnesium is connected to carbon. And moreover, this is also called as Grignard reagent. So Grignard reagent is considered as the organometallic compound. Grignard reagent. Clear? So the answer is D is the correct answer. So 58 is answer D. Let us go to the next question, that is 59. A pair of compounds having the same building points, same boiling points, this one, same boiling points are, listen carefully, a pair of compounds having the same boiling points are, first option they have given benzene and naphthalene, second option butane 2-ol and butane plus butane 2-ol and minus 2 butane 2-ol, third one cis-but2-ene and trans-but2-ene, fourth one n-hexane and neohexane. And all of you observe carefully, in this if you clearly observe, benzene and naphthalene, their molecular formula is not same. If molecular formula is not same, then definitely there will be boiling point variation. Why? Because as molecular weight increase, boiling point increase. So first one is not the correct answer. When if you go to second one, here what happened? Plus butane 2-ol and minus butane 2-ol. These two are just optical isomers. Optical isomers having only difference in its optical rotation but not boiling point. So what happened? Here boiling point of both will be same. They are asking same boiling point. So this is the correct answer. But if you analyze the remaining also, cis-2-butene and trans-2-butene, they are geometrical isomers. Geometrical isomers, definitely there will be difference in boiling point. So third option is geometrical isomers. So geometrical isomers have variation in the boiling point. What about the n-hexane and neohexane? Definitely here what happened, whenever branching increases in hydrocarbons, boiling point decreases. So definitely what happened here, I will write the reason, branching increases, boiling point decreases. So the only option left in this one is B, whereas these two are optical isomers which are having same boiling point. Let us discuss the last question of our paper, that will be 60th question. Identify the A, B, C in the sequence. They have given ethyl bromide, when it is reacting with alcoholic KCN, you got A, which on reacting with lithium aluminum hydride you are getting B, which on reacting further you are getting HNO3 in the presence of 0 degrees centigrade you are getting C. So we have to discuss what is A, B, C. First you people know very well, for example if I take CH3, CH2, Br, when it is reacting with alcoholic KCN, what happens? This cyanide will be simply substituted with Br, that is a nucleophilic substitution reaction. So you are going to get CH3, CH2, Cn you will get. And the next one, when we are making it react with lithium aluminum hydride, then what happened here? Cyanide will be reduced to amine. So you will get answer like CH3, CH2, CH2, NH2, you will get amine. And the next amine, we are making it react with HNO3 at 0 degrees centigrade. This process is called as a diazotization. This process is called as diazotization. So in the process of diazotization, what happened? There will be a formation of diazonium salt. So what happens here? We will get CH3, CH2, CH2, and you will get N2 plus, and what about here? And whatever the counter is that will come. But as they have only HNO3, you will get simply diazonium salt formation takes place. But remember, aromatic diazonium salts are stable, but aliphatic diazoniums are unstable. So that is the reason why here what happened, by using its bonded electrons, N2 gas will go out. So after removal of N2 gas, you will get CH3, CH2, CH2 with positive charge will come. Is it clear? Now this one what happened, from the moisture it will take OH minus ion. From the moisture it will take OH minus ion. That OH minus ion will attack on this carbocation and you will get CH3, CH2. Remember carefully here, CH3, CH2, CH2, and you will get OH over here. So the option what we have, that will be, C. Right, clear? That's all. Thank you very much.